So hi everybody. So it is a continuation of the same chapter, that is file system of module 4. In the previous lectures we have covered the two topics, that is file concepts and access methods. And in the previous part of the next part of the syllabus we are going to cover the directory structures, how the files are going to be organized in the system. So we'll start discussion of the directory structure. We'll go on discussing one by one here. So what is directory structure, or why we are using the directories to organize the file in a such a way that we can access the contents or the files efficiently. So how we are going to organize, we'll go on discussing. So here directory structure means, what is a directory here? Directory is also called as a one type of file where collection of nodes containing the information about all the files. Means directory does not contain the information, it contains the files and sub directories here. So here the circles are going to represent directories and the square boxes are going to represent a file names, f1, f2, f3, f4, ef, and so like that. You can create any number of directories and you can create any number of files under these directories. Both the directory structure and the files reside on the disk. Backups of these two structures are kept on a tapes. These all files are going to be maintained in the disk, and if you want to keep backup of these files, we are going to use the magnetic tapes. And this is how actually typical file system organized in your computer system. So consider this is a disk. It is divided into three partitions, A, B, C. The first partition, it is called as a directory. Under this we are going to have the files like this. Directory files, it is a partition 2 in the disk 1, and there is only one partition C, we are going to call it as in the disk C here. So there is only one partition in the directory. That partition name is called as C, and it contains 2 and 3 disks here. So for example, in our computers we are dividing the single disk into a different partitions like C, D, E. Those C, D, E are called as the main directories. Under that you are going to have the files and subdirectory. This is one example of the a typical file system organization in your computer systems. So once you got it, the organization of the computer systems, file system organization, will go for the operations performed on the directory. How the operations you are going to perform on the file, same way we are going to perform the operations on the directory. Some additional operations, those also we are going to use here. One is search for a direct file here. So as you know, in the file system, if you are not able to locate the file or where you kept, you are using the option called as search in the Windows or Linux operating system. So just you click on that search operation, and if you typed, it will locate that file where it is stored here. It is a simple way to search the file in a system. So like that we can create the directory files, we can delete the directory files, you can list the directories, you can even rename a file, and you can traverse the file system using the directories. And directory is also going to maintain the information of the file attributes, and these all going to be maintained in the disk. And even the one more feature of the directories, that is a mapping of file name to a identifier. Usually file names are going to be known by the user, and those are not going to be referred by the system. So this computer system or the operating systems are going to use the identifier, so that mapping of name to id and id to name is going to be done at the directory level. So organize the directory to obtain. So what are the features or the benefits? So that is, first one is efficiency, locating a file quickly. So to store and access the file or locate the file quickly or faster, efficiently, we are organizing the files using the directory, and naming convenient to the users. Two users can have the same name for a different files. You can create the two directories for two different divisions A, B, and we can save the same file name on a two different directories, and the same file can have also different names. So this is another benefit of organizing the files using the directories. Another one benefit we can get here, grouping. That is logical grouping of the files by properties. If you consider our college, we can group the contents or the notes by department wise or subject wise. So like that, if you want to make a groups, we are using the organization of the files using the directory structures. Once you got to know what is the benefits or what is the directory structure and what are the benefits of the directory, we'll move to the next. What are the different levels of the directory structures? There are different levels of the directory structure: single level, two level, tree level and cyclic and general. These are the different levels of the direct structures. We'll go on discussing one by one. Once you got to know what are these, and we can get to know what are the problems and advantages of this direct level structures. So first of all, we'll see the single level direct structures here. A single directory for all the users. There is only one directory in a computer system, and all the users are going to store those all files in the same directory. Means what is going to happen if there is a department considered as a computer science. So instead of maintaining the separate directory for all the subjects and all the semester, we are going to keep all the student information and subject information at a single level. Then we are going to face the problems here, that is called as a naming problem. For example, if you want to maintain the roll number files, so you are using the file names same roll number or student list, then it is going to face the problem. Even we can also, cannot able to grouping problem also we are going to face. For example, which are the subjects belongs to a third sem, fourth sem, fifth sem, sixth sem, seventh sem, like this, or the subjects related to the computer science and subjects related to the first year electronics, like that we cannot easy to group them. So these are the problems we are going to face with a single label directory. Even we cannot name the two files, we cannot keep the same name, or we cannot maintain the two different files with the same name. That is another problem we are going to face. To overcome these two problems, we are using the next level of directory structure called as a two level directory structure. So here separate the directory for each user. Here, instead of maintaining all the information at one level, what we are going to do, instead of taking a semester, they are considering the user. If there are four users, then we are going to create the four different directories, that is called as a user 1, user 2, user 3, user 4, and the contents of those files are going to be maintained separately in the different. So here, if you want to access the file, or if you want to locate the files, in this method we are going to use the path names. Path name means you are going to give the file name here it is located. For example, if the file resides in the D drive, then you have to give the D forward colon forward slash third sem forward slash student list, like that we can access the files. And we can have another advantage of this two level directory structure, that is can have the same file name for different users. For example, if you see the diagram here, a we have maintained for the user 1, a we have maintained for the user 2, a is also there for the user 3, a is also for the user 4. The same you can give, if even there is a different content, we can give the same file name. Even one more advantage we can get here, even if there is a content same file, you can give the different file names. So that is another advantage we can get here, that is naming problem is avoided using the two level directory structure. Another advantage over the two level directory structure, that is efficient searching. We can easily you can get the access to the files. If the user want to access the files, they can directly access their part of the area, or in there under that directory he or she can get the files easily, and no grouping capability here. But the problem we are going to face with this structure is no grouping capability. If the user one want to maintain the information of the two different labs, or different subject information he or she want to separately, then it is not possible with a user one or a student one. So this problem is going to be overcome. Naming problem we have overcome, but the grouping capability is not overcome here. To overcome this, we are going to use the next structure called as a tree structured directories. So here we are going to consider the tree structure, means we are going to organize the files in the tree hierarchical structures. There is a root, you have studied in the data structure, root, then the subtrees, then followed by the subtrees. The root is always directory here. The root are the directories, and they are going to have spell. For example, spell is a directory, bin is a directory, and programs are the directories. Spell again going to have a subdirectories and files here. In this spell, mail is a subdirectory, stat and dist are the files here, like that. Again, mail has a four directories, prog, copy, and prt are the three directories, exp is the file here. Means simply what we are going to define, intermediate levels are going to be called as a directories, and the leaf nodes are going to be called as a files here. This is a what how we are going to organize the files or directories, not files, directories in the tree structured hierarchy here. So whatever the problems we have faced previously, that is naming is overcome, but the grouping is not overcome. There is a problem with grouping in the two level that we are overcome here. For example, programs, you consider the another directory in this structure, programs. So there are a p e mail here. P is going to have one set of programs here, reorder, list, find, and e is another directory containing the another set of programs called as a hex and count. Even you can also create here, for example, programs. There are different programming language you are studying, C, C++, Java, like that. If you want to create the directory C, C++, Java, and you can maintain the nodes related to the C programming language, and even you can maintain the nodes related to the Java programming language. In that again you can create nodes subdirectories like nodes, lab programs, and some video lectures or some ppts. You can create the different directories and you want maintaining. This is a way how we are going to maintain the files. And even you can give the same file name in a different locations. For example, if you consider here, list is here also in the under the p, and list is also here in this spelled structure here. So like that you can give the same name for the different files, or same file name can be stored in the different names in the tree structured directory. And here we have overcome both the problems, and we also overcome the, or we can also get the files. All the three advantages that we have started searching, naming, and another advantage called as a giving the names with a different same file name with the different names. These all advantages we have overcome here. So just I will take back you to the advantages what we have got: efficiency, naming, and grouping. All these three advantages we are going to overcome using the tree structured, or we are achieving through the tree structured directories. So next, this is the efficient searching, grouping capability, and current directories, working directories, cd, spell, mail, prog, and type list. Like this is a way we are going to get the information. So here, after discussing this directory structure, we'll go to the next tree structure directory. Continue here. So there are two different path names we are using. There is absolute path name and relative path names. So for example, creating a new file is done in the current directory. Delete a file we can carry out. So for example, delete, if you want to delete the file, you are using the command called as a rm and followed by file name. So creating a new subdirectory is done in the current directory by using the mkdir command, dir hyphen name here. Example, if in current directory slash mail mkdir count, it is created here. Under the mail we have created the another subdirectory called as a count here. So deleting a mail, deleting the mail entire subtree routed by the mail here. So it will be deleted here like this. So once you got, you know, how you are using the, what is the absolute and relative path name means. So if you want to create a file under this mail and under the prog, if you want to create a c, then you have to use the relative path name called as mkdir mail slash prog slash that file name. So this is called as what? Relative path name. Absolute means you are using some absolute path names like dot and dot dot. Dot means current directory, dot dot means parent directory. Like this you are going to use. These are the some methods we are using to access the file names or giving the file name to access. So path names are the route to reach the file or to get the file location in the system or in the disk. So there is another method we are using called as a acyclic directory structure that we are going to discuss here. Another method, we are going to see another level of directory structure, acyclic graph directories it is. So if you want to share the subdirectories and files, we are using this method here. For example, root, there are two directories, dict and spell. So we can achieve all those, what we can say, instead of maintaining the same file in a different directories, we can create a one file and that is going to be shared here. Those are called as a linking files. We are going to call it as a linking files. So here consider list, all, w, and count. In the spell we are going to maintain another file called as a count here. So instead of creating these two different type files going to contain the same information and that are going to be shared by both the users or of the directory, instead of creating separately, we will create a one file and that is going to be linked here. This is called as what? Cyclic. Here we are going to call it as a cyclic. Another example you can consider list. Here also we are creating, or we are creating the link between the directories w and words are going to access this file. This is a way to avoid the space, wastage of a space. We are using this acyclic graph directories And here we are going to achieve all the problems, that is searching. We can access the file efficiently. Even you can name the file names easily, same name or the file with a different name also possible, same file with a different name. And even you can also group the files here. All three advantages are going to be achieved. If you want to share the files that in the previous tree structure hierarchical cannot be achieved, here we have achieved here cyclic graph directories. After discussing this acyclic graph directories, we'll move to the next topic about the acyclic graph. Just again, I'm going to review here two different names aliasing here. If DICT deletes a list dangling pointer solutions here, means if the file is deleted from the dict, it is the original file and it is pointing, original spell count is pointing to this. If you have deleted, the file pointer is open here. It is called as a dangling unknown location. It is pointing to the unknown location. So we can use the back pointer, so we can delete all pointers variable size records as problem records a problem. Back pointers using a daisy chain organization, we can do it, avoid the problem of what dangling pointers. Or entry hold count solution you can use. These are the different solutions we are going to use to avoid the dangling pointers. So instead of pointing to the unknown location, you can use these methods to point the pointers, back pointers. So we can delete all pointers variable size records, uh, variable size records. So new directory entry type here, link another name to an existing file, resolve the link, follow a pointer to locate the file. This is a different directory entries are going to be created in the graph level structures. Link, we are going to use the two different types of links are there, hard link and soft link, to create the or establish the link here. So finally the general graph directory, it is going to use the both combination of one all the levels, one level, two level, three level and a cyclic structure, and all the problems are going to be overcome in this method. This is called as general graph directory structure. How do we guarantee no cycles here? Allow only links to the files, not subdirectories. Garbage collection, that can also we can do here. If any wastage of space that is going to be collected and kept at one place, and that can be reutilized. Every time a new link is added, use a cycle detection algorithm to determine whether it is okay or not. Means whenever you want to share the file, there should not be exist a cycle, because if there is a cycle, then there is a problem to your system, or you can study that deadlock. If there are two or more processors accessing the same file, that time it is going to face the problem. So that's why we have to avoid the cycles when you are going to share the files in the system. This is about the directory structure and organization of the directory structures. Thank you. The next part of the lecture we'll see, next remaining part of the syllabus we are going to cover in the next lecture. Thank you.